Today's podcast is going to be on water and the amazing properties that it has for living things. We know, I believe, that water is important for all living things. You know, you can only survive for a few days without it, okay? And we just learned in our last unit how important it is for photosynthesis. I mean, without water, no food could get made, so it's pretty important to living things. But we can't even make our own food, right? We're not autotrophs, but water is still important to us. If you look at these percentages, our body's made up of a lot of water, okay? But why is water so important, and what does it actually do that makes it important to us? So that's what we're going to focus on today. What is water? We all know the formula, H2O. That means two H's and one O. So two hydrogen atoms and one oxygen atom bonded together. And the type of bond that holds them together is called a covalent bond. That's where the atoms share electrons. So this is what a water molecule looks like as a model. Okay, if you turn it upside down, some people say it's like Mickey Mouse with the two ears. So like these would be the ears, right? And this is sort of the head. So some people call it a Mickey Mouse molecule. Okay, so what's so great about water is that water is polar. Okay, so part of the molecule is negative on one end and positive on the other end. So the oxygen becomes slightly negative and the hydrogens become slightly positive. The reason for that is that the oxygen's bigger, so while it's sharing the electrons, it doesn't share very nicely. Think of like a big bully. Okay, if you were a bully and you were the bigger kid, you might not share very nicely, and that's how oxygen is. It's not sharing the electrons equally with the hydrogen, so because of that it gets a slightly negative charge and the hydrogens get a slightly positive charge. Okay, so what happens is that allows water to stick to other things. Okay, so I considered water to be like a magnet, right? Magnets have a north pole and a south pole. Well, that's why we call water polar, because it has a positive pole and a negative pole. So watch what happens here. These water molecules, they are attracted to one another. Right? Okay, this attraction between the water molecules is called a hydrogen bond. It's not very strong, it's actually kind of a weak little bond here, okay, but it's really important because it links all these water molecules together. Okay, so just so you make sure you have it written down, water's polar. Okay, polar meaning like the North Pole and the South Pole, those are two opposite ends. Well, water has a positive end and a negative end, two opposite ends, so it's called polar. And that's because it doesn't share its electrons evenly, so we call it like a magnet. Okay, so the hydrogen bond, okay, what we just saw in that movie is the attraction between the water molecules. So it's not in one water molecule. Whoopsies. What did I do? Sorry. So it's not in the water molecule, it's between the water molecules, this hydrogen bond. So here's just another animation that shows the hydrogen bonds forming. So notice it's between the H of one water molecule and the O of a different water molecule. Constantly get broken and reformed. Okay, so again, if you watch it, water, they constantly make and break hydrogen bonds. Okay. So water molecules can stick to other water molecules. This is called cohesion. And what's neat is that it creates surface tension. So if you look at the water strider here, or this guy down here is called the Jesus lizard, because he can walk on water. Now, if he just stood still, he'd fall through. The surface tension's not that strong, but it's strong enough. If you can distribute your weight, see how the spider distributes its weight out over the surface? Okay, that allows the water to hold the bug up without letting it fall through. So it's really the water that's stuck together making this surface that allows the bugs to stand on it. Okay, so not only does water attract to itself, it can attract to other substances. Go back to the analogy of the magnet, right? Magnets can stick to magnets, but they can also stick to other things, like say a paper clip, right? So this is how what we call adhesion, when things stick to other things. So the water is attracting to another surface. In this case, it's really important inside of a tree, because the water will stick to the inside of the tubes in the tree. If you recall looking at the leaf under the microscope, they had that vein, right, called the xylem. And inside that tube, the cells that it's made out of have a charge, so the water is attracted to that charge, and so the water can move from the roots up to the leaves of the tree, just because the water is attracted to that tube. And that's called capillary action. So that's the attraction of the water to the tube. Okay, another important property of water is that it has a high specific heat. What that means is you can add a lot of heat to water and it will slowly absorb the heat, and then as soon as it heats up, it will slowly release the heat. So think about when you put a pot of water on the stove. Okay, the pot itself will get really hot really fast, but the water will be slow to heat up. And then if you turn the pot off, the pot itself will cool down pretty quickly, but the water will slowly cool down. Okay, and so that's called having a high specific heat. This is important to living things, really important, because it helps us maintain a stable body temperature. Okay, so when it's really hot or really cold outside, our body doesn't change temperatures very quickly. It's because the water in it changes slowly. It's also important to living things that live in lakes and ponds, so that they're not getting too hot or too cold as the temperature changes outside. And finally, this high specific heat is also what removes the heat from our bodies when we sweat. So we sweat, the water has on the surface of our skin will then remove the heat from our body and evaporate off our skin, and so that's what allows us to cool off. Another important property of water is that it expands as it freezes and then it floats. Okay, so ice is less dense than liquid water, which is what lets it float. And this is really, really important to living things that live in ponds. Okay, right, so only if you've ever gone ice skating or fishing on a pond, right, only the surface of the pond is frozen. The underneath is still liquid. And that's really important for those living things to be able to survive the winter. Okay, another important property of water is that it can dissolve lots of substances. So let's watch here. If we take a substance like salt and we put it into water, okay, the water acts like a solvent, okay, which means it's going to dissolve it. But watch how it does it. Okay, watch. All right, so there's the salt. The Na and the Cl is what makes the salt. Notice how the water is pulling it apart. Okay, now why was the water able to pull the salt apart? Well, look at it. Okay, the salt has Cl, which is negative. Okay, notice what part of the water molecule is touching the Cl or is attracted to it. The positive part of the water pulled on the negative chlorine in salt, and then the negative part of the water pulled on the positive part of the salt, which is the sodium. So sodium chloride, which makes up salt, gets pulled apart easily by water. Okay, and when the water surrounds it, then the salt is totally dissolved. Right? So when you put salt or sugar in water, the water dissolves it. What does it mean? It means that those water molecules pulled apart those atoms, or in this case these ions, and dissolved them. Okay, so for that reason, we call water the universal solvent. A solvent, if you look at the word solvent, right, here's the word solvent, and here's the word dissolve, right? It has this solve in it. Okay, that means to break things down. So water is the universal solvent. It can dissolve many substances. Okay, why? Because it attracts to them. So as long as the substance has a charge, water will attract to it and pull it apart. Again, who cares? Why do living things care if water dissolves stuff? Okay, well, you'll notice the big chunk of salt here, okay, gets dissolved into little tiny pieces, and then it can move very easily through our bodies. If anyone who's ever had a kidney stone, okay, a kidney stone is basically just a big chunk of salt, okay, and how do they get it out? Well, usually when you pee, I'm sure you've never tasted your pee, but there's salt in it. Sometimes there's even sugar in it. But how come you don't know that there's salt or sugar in your pee is because it's dissolved and it's so small. But people who have kidney stones, they have the salt not dissolved. So they have to try to get the salt to move and through that little tiny hole without it being dissolved. So now I think you can be very appreciative that the water dissolves the salt normally, so you don't have to deal with having to pee that out. Okay, last thing here. Okay, we all have probably seen oil and water. They don't mix, right? Why is that? It's because water is polar. Okay, and now we have a new vocab word here, lipids, okay, which is basically fat and oil and waxes. They're called nonpolar because their molecule has no overall charge. So nonpolar substances like oil, they'll stick to themselves, okay, but they don't like to mix with polar substances. So anytime you have something nonpolar, anything greasy, fatty, oily, right, and you put water on it, they don't like to mix. Okay? Even your skin, if you look at your skin, okay, when you get out of the shower, the water should be sort of beating up on your skin, and that's because your skin has should have some waxes and some oils and some fats in it that keep you from dissolving while you're in the shower. So that's a good thing. But again, nonpolar substances, which are fats, oils, and waxes, which are a new category of molecule, they're called lipids. They don't like to mix with water because they're nonpolar. And that's it for today. Thank you.